Hello again. In this short video, I'm going to be looking at how to generate descriptive statistics within R. Now, we have already imported in the dataset. We first of all made a new project. We have looked a little bit at outliers, so we did a bit of data curation. We're happy now that our data is more or less as it should be. Now, in the PowerPoint slides, there were indications of which functions you can use to generate descriptive statistics, and the one that I mentioned and recommended was the tapply function. Tapply allows us to split our data according to a rule or a factor, and within each of the subgroups that have been identified, you can apply a function. So a function like the mean or the standard deviation. And this is quite useful if you are filling in the first table, table 1a and table 1b, and also filling in parts of table 2. Now, in table 1a, you'll see that for the seedling weight and also the seedling length, you'll need to be looking at the mean, standard deviation, the minimum, the maximum, the range, which is actually just the max minus the min, and the coefficient of variation. The last of those quantities is just simply the standard deviation divided by the mean, and that's important in this exercise because we would like to be able to compare the amount of variability in the data between the weights and the lengths, and these are not directly comparable because they're they've got different units and they've got different magnitudes. A bit like, for instance, you'd like to compare the variability of a bunch of mice versus the variability of a population of elephants. It's hard to do if you just start comparing standard deviations directly, but if you normalize those by dividing by the mean, you can get back to values which are more comparable, and you can say something about levels of variability across species. Now, in this case, one of the questions is which of these two traits is more variable, so you'll be needing to look at the coefficient of variation for that. Now, how do we generate these values? How do we generate these descriptive statistics? I use the tapply function. So tapply, and I want to look at, for instance, the seedling weight. So I pull out the column using the $ and weight. Now, we want to split the weight up according to the treatment column. The treatment, as you recall, is the different populations, the different genotypes that we're looking at. So that's data column treatment. So I press T and then hit the tab, and it automatically completes it for me. And the first function, for instance, would be the mean function. If I apply that, you'll see immediately now the means of those 6 different shall we call them populations, or 6 different genotypes. Of course, the mixtures are not genotypes, but they're kind of like a simulated landrace, so we will more or less call them genotypes for now. Okay, so that's the mean. I can copy that line, and if I want the standard deviation, I can use the SD function. This is all very fast and convenient. Maximum, you use max. Again, paste and put down minimum. So you can see very quickly you can generate all the descriptive statistics you like. In fact, there's another function in R called the summary function. And the summary function actually gives you sort of descriptive statistics, a bit like what a box plot would do, looking at the minimum, the maximum, the first quantile and the third quantile. So this is the 25% quantile and the 75% quantile, also the median, which is the 50% quantile, and also the mean. But you'll notice, for instance, here the standard deviation is missing. So the summary gives you some of these things, but not all of these things. If we wanted the coefficient of variation, how would we do that? Well, as I said, it's just the normalized standard deviation, I mean. So if we just divide the standard deviations by their means. Now this is of length 6 and this is of length 6, but R is smart enough to know that when you do this, you divide the first element of this vector by the first of this, and so on and so forth. So I could have, if I divide this by this, the order will be conserved between both of them, and it'll give me immediately the coefficient of variation of those 6 different genotype classes. If you notice for table 2, you're going to also have to calculate the variance of some of those. So if I put down the variance instead, so VAR instead of standard deviation. Okay, well, I just highlighted variance, and R is telling me what the variance function actually is, but that's not very useful. I actually meant to highlight the whole line, and here you see the variances. That's just the squared standard deviations for those 6 different groups. I think that should be enough to help you in filling in table 1A and 1B, and also filling in parts of tables 2A and 2B.